Alright, so velocity versus time graphs can be even more complex than distance versus time graphs. There's a lot more we can do with these. First, let's look at what I have here. I have, again, positive and negative y part, and I have a time, which is, again, the time is along the x, the velocity is along the y. It's also super important to make sure you always look at what kind of graph you're dealing with. Is it a position versus time, velocity versus time, or acceleration versus time, or any other kind of graph? There's numerous kinds of graphs. For this one, what I have here, which I didn't really label it, but let's just follow the cursor. Here, you'll notice that it's a horizontal line. Now, in a position versus time graph, a horizontal line means you're not moving because the slope is 0, your distance doesn't change. But in a velocity versus time graph, that's totally different. In velocity versus time graph, if it's horizontal, it means you are moving. You are moving, but you're just moving at a constant rate. You're constantly going 2 meters per second, or whatever the units might be, miles per hour perhaps. We'll just say meters per second because that's standard. So for this one, I'm constantly going 2 meters per second east, because again, this is velocity. So anything here above, okay, anything above, which is again the positive y, is east direction. Anything down here is the west direction. So what this is saying is I'm moving at a constant 2 meters per second east. Then notice my velocity starts to slow down. Well, how do I know it's slowing down? Because my velocity went from 2 meters per second to 1 meter per second to 0. Now, what this means, a negative velocity here means I'm slowing down. Now, I'm still moving east. Just like when you run, you can run and slow down and you don't change your direction. You're just slowing down in the same direction. So everything here is east. Everything here is east. I'm moving at constant rate east, then I'm slowing down, but I'm still moving east. Once you cross this line here, though, once you cross the x-axis and go into the negative y, now you're literally changing your direction. Right when I got to right here, I stopped. Then I started to speed up again, but this time I'm speeding up. Notice my velocity is getting higher and higher, but I'm moving to the west. So now I'm going faster in the west direction. Then again, I come and I hit like cruise control, and I'm going at a constant negative 3 meters per second in the west. Again, that negative just means I'm going in the opposite direction. Then when I get to here, I'm still going west. I'm still moving to the west, but I'm slowing down until I come to a stop at 11 seconds. So for the first 3 seconds, I'm moving at a constant 2 meters per second to the east. Then I start to slow down for 1 second. I come to a stop very briefly, and then I start to speed up, but this time I'm going in the opposite direction to the west. I go at a constant rate in the west, then I start to slow down, but I'm still moving to the west until I come to a complete stop. So that's what that's saying. For a velocity versus time graph, if you were to calculate the slope, which is still y2 minus y1 over x2 minus x1, this is important. The slope in a velocity versus time graph means acceleration. Repeat that. In a velocity versus time graph, when you calculate the slope, that is acceleration. So which is the change in velocity. So when you look at the very first slope right here, if you were to calculate the slope, you would see it's 0. The acceleration is 0 because there is no change in velocity, so it makes sense. If you found the acceleration here, it'd be a negative acceleration, which means you're slowing down. If you found the acceleration here, okay, again, it just means you're speeding up. You're going faster. The slope acceleration would be 0, and then here you'll notice it'll be slowing down. So again, in a velocity versus time graph, slope is acceleration. But there's also something else you can do in a velocity versus time graph. You can find displacement, the total movement. How? You find the area of the graph. Area. The area equals displacement. area equals displacement. And we're going to do that right now. Easiest way of doing this is to create rectangles and triangles. So, for example, we're going to find the area first for this part. So we'll find it here, and then we'll find the area here. So the first rectangle I'll make is this one right here. And so what's the equation for area of a rectangle? Well, that's just base times height. So that's pretty easy. Area, write that equation down for you. Area of a rectangle is base times height. So this one went over, oopsies, there we go. This one went over 3, 1, 2, 3, up 2, so 3 times 2 is 6. So the area for this one is 6. Pretty simple. The area of a triangle is 1/2 base times height. So for this triangle right here, notice the height is 2, the base is 1, so it'll be 1/2 times 1 times 2. So again, I'm not showing all my work. We're trying to do this in our heads here. Half of 2 is 1, and then 1 times 1 is 1. So the area of this triangle is 1. Notice, when I do these areas, I don't go all the way down here where my mouse cursor is flying around. Okay? You go until you hit the x-axis. So if the slope's up here, you go down until you hit the x. For this part, we're going to go from the slope until we go up until we hit the x. So for this triangle, we have a triangle here and a triangle here. Now this isn't exactly perfect. I did this by hand, but trust me, they're triangles and squares or rectangles. So I have a triangle, a rectangle, and a triangle. So let's find the area for this one. And because it's in the down, these are going to be negative. Or you can make them positive and subtract them. It doesn't really matter. It's your choice. Your choice. So for this one, it's over 1, 2, and down 3. So half of 2 is 1 times height of 3. So I can say this one is -3. For the next part, let's see. 1, 2, 3. 1, 2, 3. So 3 by 3, that's a square. It's -9. And then for this one, 1, 2. 1, 2, 3 is the height. 1, 2, 3 is the height. So half of 2, half the base is 1 times height. So that's another -3. Next, add up the total areas for each section. So in the east, the total is 7. For the west, -3 plus -9 plus -3 is -15. Okay, now there's different ways you can write this. You can either do, there's many different ways. You could do 7 plus -15, that's one way. Or you could do, and if I do that, I do 7 plus -15, okay, I'll get -8. Now, -8 meters. If I say 7 is the positive, then I have to say -8 meters east. And you're going, but Mr. Osborne, why is it east? Okay, the bigger number's in the west. That's fine. So what you could do then, you could, remember that negative just flips the direction. So you could say +8 meters west. That's one way of doing this. That's one way. Another way is, what I like to do is I like to make the biggest number the positive. So since west is bigger, I'm going to make that the bigger one. And then I'll make the other direction, the smaller direction, the negative, or I can just minus it. So I'll say 15 minus 7, or you can do 15 plus -7 equals 8 meters west. Because I said west will be the positive. So there's different ways you can do that. So once again, for velocity versus time graphs, Horizontal lines mean you are moving just at a constant rate. Depending on if it's above the x, as in you're in the positive y or the negative y, the down slopes and the up slopes can mean totally different things, but slope is acceleration. And then to find displacement, you find the area of the slopes. You find the area of the whole graph, just like I did there. And again, best thing to do in my opinion, make the biggest one the positive. So in this case, west was the biggest, so I'll say positive 15. Then make the smaller one, in this case east, the negative. So I'll say 15 plus negative 7 or 15 minus 7. And there you go. Next, we're going to look at how to change or what all the different symbols mean and how to go from a distance to velocity to acceleration.